Hi friends, welcome to my channel Electrical Tales. Let me ask you one simple question. Have you ever opened a circuit diagram, seen resistors and wires everywhere, and thought, where do I even start? Today's circuit looks exactly like that, but the goal is very small. Find the current through just one resistor. Here's the secret. You don't need to solve the whole circuit. We can shrink the entire network into one battery and one resistor. This small idea is called Thevenin's theorem. Today I'll explain it like a simple story, step by step, so even beginners can understand. If you are new here, please subscribe and let's aim for 50 likes. Now come, let's enter an electrical workshop and meet today's hero, Mr. Thévenin. Imagine a small electrical workshop in the evening. Only one bulb lights the room. On the table lie wires, resistors, batteries, and meters. On the blackboard, there is a big and confusing circuit. Wires cross everywhere. It looks scary. A student looks at the board and says nervously, "Sir, this circuit is too big. How do we even start?" The teacher smiles and says, "Don't worry, let me tell you a story." The teacher points to the circuit and begins. More than 100 years ago, in 1883, in France, an engineer named Léon Charles Thévenin had the same problem. He worked with telegraph circuit. Those circuits were very long and very complicated. Every time a new device was connected, engineers had to solve the entire circuit again. Thévenin got tired and thought, why should I solve everything again and again? Then he had a simple idea. When a load is connected to a circuit, the load only sees two terminals. It doesn't know what is happening inside the circuit. So, from those two terminals, even a very big circuits behave like a small simple circuit. The teacher arranges the board, then he draws one battery and one resistor in series. The students look surprised. Here, we start with the definition. The teacher says slowly, this is called Thevenin's theorem. Thevenin's theorem says, any large and complicated electrical circuit can be replaced by one voltage source, VTH, one resistance, RTH in series, when seen from the load terminals. This small circuit gives the same voltage and current to the load as the original big circuit. Now the teacher writes on the board the formula. Thevenin's voltage, VTH is equal to open circuit voltage across the load terminals. Thevenin's resistance is the RTH, resistance seen from terminals after the turning of all sources. And next, load current, IL is equal to VTH by RTH plus RL. He says, these three formulas are enough to solve many exam problems. Next part is derivation. Now the teacher says, let's do the simple workshop job. We can take some simple steps. In that first one, remove the load. First, remove the load resistor. Forgot it for a moment. Next step, we have to find Thevenin's voltage. Now measure the voltage across the open terminals. This open circuit voltage is called VTH. Next, find the Thevenin's resistance. Now turn off all sources. Voltage source, short circuit. Current source is open circuit. From the same terminals, calculate the resistance. This is RTH. Next, we need to build a small circuit. Now draw one battery of value VTH and one resistor of the value RTH in series. Reconnect the load. And the last, the teacher connects the load again. The bulb glows exactly the same as before. The teacher smiles and says, see, the circuit looks different, but it behaves exactly the same. Let us solve the given circuit using Thevenin's theorem. Our aim is to find the current through the load resistor 6 ohms. First, remove the 6 ohms resistor. Now to find Thevenin's voltage. After removing the load, only 2 ohm and 4 ohm resistors are active. They are in series. So the total resistance is 6 ohms. Supply voltage is 6 volts. So the current is 1 ampere. Voltage across the 4 ohm resistor is V equal to I times R. So 4 into 1, 4 volts. So the final VTH Thevenin's voltage is equal to 4 volts. Now a common doubt. Why don't we consider the right side 2 ohm resistor? Because the load is removed, the side is open. Open circuit means no current. No current means no voltage drop. Next, to find the Thevenin's resistance, turn off all voltage source. Replace it with a wire. Now we have 2 ohm in series and 2 ohm in parallel 4 ohm. Parallel value is 1.33 ohms. So the final RTH is equal to 2 ohm plus 1.33 ohms. By the final value, RTH is equal to 3.33 ohms. Now reconnect the load resistor. The load resistor is 6 ohms. So the total resistance is R total equal to RTH plus RL, which means 3.33 ohms plus 6 ohms. The final answer is 9.33 ohms. To find the load current, IL is equal to VTH by R total equal to 4 by 9.33. In the final, the load current is 0.43 ampere. We didn't solve the full circuit. We changed the big circuit into a simple voltage and resistance. This is how Thevenin's theorem makes circuit problems easy and simple. We didn't solve the full circuit. We changed the circuit into simple battery and resistance. That is why Thevenin's theorem makes circuit problems easy and fast. If this story helped you understand Thevenin's theorem, please give this video a like. And if you are preparing for exams or want concepts explained in simple, story-based way, don't forget to subscribe the channel. Until then, keep learning, keep simplifying, and I will see you in next video. Thank you so much.